So why you want to learn this course? What is the requirement? And did anybody ask you to learn this course, or is it is your interest? What is your experience towards this course? I just want to know about yourself. So can you please tell me why you want to learn Docker and Kubernetes? Yeah. Can anyone start from? Can anyone start? Sure. Aman, Gaurav, Vishnuvardhan, anyone?
Good morning, Chaitanya.
Good morning, Kishore.
Yeah, actually, my background is a Java developer.
Very good.
To deploy the application and build the images through Docker and deploy the application to containerization, I need some DevOps support. So we are planning to do the all the work as a full stack. So we need to do the DevOps work also as a developer side. That's the reason I need some Docker and Kubernetes technical stack.
So yeah, so you are saying that you are from Java background
Exactly.
and you want to learn Docker and Kubernetes so that you can do the deployments, okay, to the containers and the managing that containers. So that is the reason why you want to
Yes.
learn this course, right?
Yes. To deploy those into the clusters environments.
Yeah, I understand that. Okay. So that's fine. So do you have any prior knowledge on how deployments will happen? Do you have any understanding about that?
Like our deployments, especially on the on-prem as well as the PCF environments, not in the clusters environments, like in the
No problem.
Kubernetes.
No problem. We'll discuss about that. Okay. Thank you, Kishore. Gaurav, you said something. I just gone through that message. What is it? Yeah. Need to use the Kubernetes at work to deploy the applications. Okay. So you want to learn that you want to deploy the applications in the work environment. So that's the reason you want to have a clear cut understanding about Kubernetes. Okay. Yeah, Aman. Go on.
Yeah, so I do have a little bit of knowledge on Docker and Kubernetes. So the main reason is, I mean, mostly every organization is trying to be platform independent. So they are moving towards Docker runtime, and definitely we need to learn Kubernetes with it, just for orchestrating the runtime, Docker runtime, or the containers, and also scaling and resiliency. Everything is easy to achieve with already this Kubernetes platform out of the box, rather than doing the traditional system administration work. It's very much reduced with the help of Kubernetes.
Okay, fantastic. That's fine. A clear cut picture you have given. Okay, that's okay. Okay. Yeah. Next, Ram. Yes, Ram is there. Okay. I'll go with Vishnu.
Hi Chaitanya, good morning.
Hi,
So
Vishnu. Good morning.
actually, I got to work in a project where it used Java Kubernetes client, where they create pods in the runtime based on the user input. So in order to have more knowledge on such products,
Are you a developer?
yes, I'm a full stack developer.
Good. Okay, then I totally understand. So here I can see a few developers out there. That's fine. Thanks, Vishnu. So you want to learn Docker and Kubernetes so that you want to deploy the applications on that cluster and how we can run the applications on the cluster. That's the reason you want to learn it, right?
Yes, correct.
Yeah. Just give me a second.
And Chaitanya, actually, I'm a little bit confused also. See, as a developer, I will not have opportunity to get into cloud console and all
Hmm.
in real time when I work. So in that case, do I really need to learn, put my effort in learning cloud environment and CI/CD, or just the Docker and Kubernetes
No
level
need to
knowledge is
see.
fine for me? So at that, I'm in that confusion, you know?
I totally understand you. Just hold on a second. I will clear that for you. Okay. So let me introduce about myself, and then I will go into the concepts of Docker and Kubernetes, what you are going to learn and how you are going to work with the concepts. Hi everyone, I am Chaitanya. I am here with an experience of 14 years into the IT industry. I work for an top MNC company as a DevSecOps engineer in the level 5 consultant. Level 5 consultant. And I have my certifications related to Kubernetes. I'm a certified Kubernetes administrator, and as well as I'm having my AWS professional level certification, and I'm having my Red Hat and Microsoft certifications. So these are the certifications which which I currently have. And then when I come back to your questions, so do we need to have a basic understanding about the cloud to understand Docker and Kubernetes? Here, whatever the Docker and Kubernetes that we are working with, or else whatever the containerization and orchestration that we are working with, we will be deploying the clusters on the AWS environment. Okay. So if you have a very basic understanding about what is AWS, how easy to instances are creating, so that would be great. No, sir, I have a virtualization platform. I'm having my virtual missions. I will create the Kubernetes cluster in the virtual missions. You can easily create that. So it is not a very big deal that you have to have a very good knowledge on AWS. If you have a knowledge on virtualization, then also you can do that. No, sir, I don't have that knowledge also. If you have a computer that is having uh, minimum 8 GB or 16 GB of RAM. Any computer or desktop that you are having 8 GB or 16 GB of RAM, that's more than enough. You can create your own Docker desktop. You can install your own Docker desktops, and inside that you can create your own Kubernetes cluster also. So it's not an we need to have a very good understanding about the AWS environment. But whenever we are working with a certain configurations in Kubernetes, especially with the services, if I have to create a load balancer service, then you need to have a basic understanding about the AWS environment. Here, I am not going to tell you that you need to have very good understanding with ES3 buckets, DynamoDB, Route 53. So these are all not required. You need to have a very basic understanding about EC2 instances, how instance will be created. That's more than enough for us. So that is one of the dependency. That too, as we are deploying the cluster in the cloud environment, you need to know about that. So if you have your virtualization platform on core, so if you have your virtualization platform ready, then you don't need to have this configuration also. So now let's discuss about what is this Docker and Kubernetes. Is your question clear? Whoever has asked this question.
Yes, Chaitanya, I'm good.
Okay. Now let's discuss about the Docker and Kubernetes. So what is this Docker and Kubernetes? You might have a few more questions. I'll give the chance. Whatever you are having the questions, I will give the chance by 9:15. Right now the time is 8:45. So I will give you the chance at 9:15. 9:15 to 9:30 is your questionnaire time. You can ask me all the questions, whatever you have. So until then, please write it down on a paper or else on a notes. Okay. So now let's discuss about the Docker and Kubernetes. So everyone know about that. We need to have a very basic understanding. Nowadays, each and every company is requesting the candidates. Either it might be a developer, or else it might be an administrator, or else it might be any person who is joining into the technical part. So they need to have a very basic understanding about the Docker and Kubernetes. If they don't have the Kubernetes knowledge also, that's fine. But at least they need to have a very basic understanding, or else at least they need to have a very good understanding about the Docker containers, what is meant by container and everything. So now if you can see, before we go into the Kubernetes concept, first of all, let us understand the Docker. Docker is the base for your entire Kubernetes. Why Docker is the base for Kubernetes? First of all, you need to understand what will be there inside the Docker. So inside the Docker, we will have the containers. What are these containers? So before you understand about these containers, let us go back to some 20 years, like 20 or else 2005 or 2010 at that particular time of at that particular time. Now, when you see there, we don't have these kind of technicalities. So Docker, Kubernetes, DevOps. At 2005, nobody knows that there is a job called as DevOps. DevOps engineering is there, so nobody know about that. And only a few people know about the system administration. System administration is the only job. Previously, also I started my career as a system administrator. Right now, I'm a DevSecOps engineer. But altogether, that's a different story. The point is, everyone are very lean towards the system administration. What is the system administration? So, whenever you are having an IT company, so now what is this IT company? In general, in the entire world, if you take any company, the company either comes under either IT or non-IT sector. Only two companies are there. One is the IT company and the other one is a non-IT company. So those who provide the technical support, those who provide the applications, and those who develop the applications, they all comes under the IT. And those who access those applications and run their businesses, they will come under the non-IT sector. So like banks, hospitals, entertainment sector, or else ticket booking, these are all comes under the non-IT sector. So for those, you need the support of IT. So now what is happening here? This non-IT guys, whoever are the non-IT guys are there, they don't know how to develop the application. They have that idea about how to create a business, how to do the business, but they don't have the clear-cut knowledge about creating the application. Now what they will do? They will reach out to a particular IT guy. Okay, they will go to an IT company. So inside this IT company, there will be a inside this IT company, there will be a set of developers, system administrators will be there. 1 second. So there will be a set of developers and there will be a set of system administrators. Those people will be there inside this IT company. Now, what is the work of these people? So now, when the non-IT guys or else the person, the owner of that company reaches to the IT company, they will completely expose or else they will completely say that these are my requirements. For example, a banking company has came to this IT company. They are requesting that we as a bank will provide some user user ease of things for the users. So what are the services, user services, I will call it as. So what are the services that they are provided for the banking sector? The bank services are, the first one is user management. So I want an application or else a microservice for management, user management. And the second one is for administrator console, admin console. This is handled by the banking team. And the next one is banking services, banking services. Here you will have other two types of services. One is the internet banking and the other one is the mobile banking. So they will ask like this. And the next one is under internet banking, again, I need to have a few more services like a and corporate. Retail and corporate services. And then they will ask that we need to have a wallet service. And then they will ask like billing services. Okay, so like that, they will ask so many services in order to make the customer very application friendly. Okay, so I want an application that should be very close enough to the users, so it will provide certain discounts and the user will be continuously using that application for their transactions. So such kind of application is what we require. So we have to develop that application. So now what happens here? So when this non-IT guys reach out to this IT guys, So these IT guys will gather the complete information. So what is your requirement? Can you please explain us? So they will gather the complete requirement. So that is called as a requirement analysis. Requirement analysis. Requirement gathering and analysis. Okay. And then what they are going to do here, after requirement gathering and analysis, they are going to design the application. So what is the user requirement? The user is requiring like this. So these many number of these are the front end services. This is how the front end should be looking like, and this is how the back end should be looking like. This service should be connected to this back end. So like that, they are going to design the application. Okay. And the next one is, once they have designed the application, they will start implementing the application. Okay, they will start creating the application. So there will be multiple teams will be there. So let us go with the development team. In development team, there will be front end developers who is going to develop the front end, and there will be back end developers who is going to write the services, like Java developers, Python developers, .NET developers. There will be back end developers or else service developers who is going to write the code for services. Either it might be Java, or else it might be Python, or else it might be .NET. Uh, or else it might be Ruby, Golang. So different kinds of backend languages are available. Depending on that, they are going to write the services. And the front end, we can go with the React, Angular, like that. HTML, CSS, JavaScript, everything will comes under these tools. So yeah, the front end developers will develop the front end application. The user interface, UI and the UX, user experience, will be created by the front end developers. And then once the backend is once the services are the people who are writing the services, they have to connect to the databases. So in the backend, there will be database management. So like MySQL, Postgres, or else MS SQL, Oracle. So these candidates who are excuse me, these candidates whoever are developing the application in this fashion, the front end, back end, and the database management team, and then you will have the testing team. Okay, who is going to test the applications with the help of manual or automation like Selenium or else any automation tools that they are using. So they are all comes under the development team. So these development guys will develop the application. So once the implementation phase is completed, now comes the deployment phase. Okay, so the application has created, and we have to deploy this application. How we are going to deploy the application? For example, if you have created a Java application, that source code, whatever the source code that you are having. For example, let me show you something like this. So you are going to write the Java application in this fashion. You will have the pom.xml, and this is this is what it's a Spring Boot application. This is the source code. So this source code should be converted into the application format, that is into the jar file. So how we are going to convert that source code into the jar file? With the help of building, with the help of Maven, we are going to generate the jar file. So now that jar file should be running on a server. So now what is going to happen? This developer will say that in this location, we are having the source code. You need to develop the application from that source code. Now there will be, so sometimes developers will give me the jar file. So before this DevOps has came into the picture, the system administrators will only manage the systems. Systems are servers. So who is responsible for this? The operations team is responsible for this. So what this operations team is going to do here is, they are going to understand the system requirements, the company requirements. They will start working with the servers. So they will build the servers. So whatever the new servers that are available in the market. So if the company is requiring those servers, they will purchase the servers. They will build the servers. They will install the operating system. They will install the securities. They will remove the vulnerabilities and everything. So they will configure the networking. Okay, They will configure the networking, they will configure the firewalls, they will configure the servers, they will install the application inside the servers, they will run the applications inside the servers, and then they have to maintain the servers, and they need to take the backup of those applications every day. So these are all the functions of the system administrators, or else these are all the functions of the operations team. Now, once the developer has completed their application, they will submit this application to this developer. So we have created the application, and this is the application. Please deploy the application inside the server. So this application will not straight away go into the production environment. So what is meant by production environment? There will be certain environments that are available for the end customers. So the first one is, first we have to develop. So that is in the development environment. In the development environment, there will be a development server. Dev server will be there. So inside this development server, whatever the application that is created by the developers will be deployed. So here there is a server, and this is the application which is getting deployed into this development server. So this is my app, and this is the dev server. Okay. Now this testing people, whoever are the testing people are there, they will access the application which is running on the development server, and they will test the application, what are the bugs that are available on that application, and what are the vulnerabilities that are there, what are the minor changes, and what are the major issues that is there in the application. Everything will be tested by the testing people. So once that application is fine, once that application is tested, so here what is most important? So the operations team is most important to create that application, to run that application on the server. So once the application is running on the server and tested by our testing people, and it is set that it is good, then it will go for the UAT. UAT, or else I will call it as a staging. Staging, I can call it as staging environment or UAT environment, user acceptance testing. So the application has to be again deployed onto another server. Either it might be on the user environment. Here they will have their own servers. They will provide their servers. We have to deploy the application on the server so that the user will understand how the application will work. And user in the sense, the non-IT guys, the banking team will understand how that application will work. And if they are satisfied with that application, then they will allow that application to be sent into the production environment. Then there will be production environment. So in the production environment, production means making it live. Okay, production environments, you will have the prod servers. So these are the most important servers that are in the entire IT, whatever the IT application, wherever the IT application is running. Production servers are crucial servers. So they are very, very important. So sometimes what is going to happen, the banks will say that the application should be running on their premises. So we will provide the infrastructure for you. So the bank will say that, so that they will provide the required infrastructure for us. We have to run the application on that infrastructure. Okay, so here you will have the staging servers or UAT servers. Both will be given by the non-IT guys itself. We don't need to work on that. Okay, but development server is our responsibility. Anyways, so there will be the production servers, they are going to be provided to us. So in this production environment, we have to deploy the application, whatever created by our developers. So this will be happening. So this entire process is called as software development lifecycle. Whatever you are seeing here, this is called as software development lifecycle. So here, what is going to happen once the application is deployed onto the production environment, this application will be given access to the external customers. So whatever the banking applications that you are seeing on these browsers, for example, ICICIbank.com. So this is in the production server. For example, HDFCbank.com or else HDFC, here you can see. So whatever the applications that you are seeing, the front end, and when you log in, how you are going to your services. So those are all running on the production environment. So which means that the application is cleared all these stages, development, UAT, and finally it is going into the production, and that will be available for the end customer. So this is what going to happen. Once the application comes into the production environment, then the user has to maintain, or else the IT industry guys, the service guys has to monitor and maintain the application. So this is called as monitoring and maintenance, which will be done with the help of Prometheus, Grafana, and then there are so many other tools like Nagios. So these are all the tools that we are going to use to monitor that application, how the application is behaving. Everything will be recorded, and then any new upgrades are there, those upgrades will be given for that application. So this is called as the software development lifecycle. So do you understand the point here? Any questions up to now? Any questions? Everyone? Any questions? See, one thing that I just want to say you, I don't want the students who are sitting calmly. I want the students, or else I want the trainees who are more active. I don't want anyone to be sleeping in my session. So if you are more active, our session will be more and more live. If you are sitting calmly and saying that your trainer will continuously say, I don't need to say anything, then that won't happen in my sessions. Please try to understand. Okay. Any questions?
Chaitanya, I have a few points. Maybe end of the session we will discuss. Uh, Maybe it will be. My question is very far away, fast away, not the correct time. Definitely, we will discuss in the end of the session.
I'm good, Chaitanya. We can continue.
So this is about the different environments which you are having and how you are going to work. Now, okay, this is all fine. Where this Docker fits in. So you are saying this the software development we are going to do, and we are going to work. This is how the software development is going to happen. The application will be deployed on the servers. Everything is fine, but where this Docker fits in. Now let us discuss about that. For example, in development environment, we are the ones. So the system administrators and the developers will have a close contact. They will communicate with each other and they will understand what are the requirements. So they are going to, so the system administrators or else the operations team is going to provide the server depending on the development requirements. Okay, development requirements. So sometimes what is going to happen, so we are talking about the on-prem environment. So there will be on-prem. On-prem in the sense we have an office. Inside the office, either we can have a server room. If it is a startup company, we don't offer more amount of money. We cannot invest more amount of money on the infrastructure. So we will purchase a single server. Inside the single server only, we have to do the development. So that's the one stage. Or else we will tie up with the nearest data centers. So these data centers will provide the servers for us at a particular reasonable cost. So when we are working in the on-premises environment, we will go with a data center. So we will approach a data center and say that these are the requirements for our company. So if you can provide the servers at a very low cost, we will deploy the applications onto that servers and test the applications so that these servers will be the development servers. We don't want to expose those servers for any external users. So we don't want heavy high security for those servers also. We want to only access for the application purpose. So if you say that, then this data center will provide the physical servers for us. So they are going to provide some servers for us. So these servers, we are going to run the applications. So previously what we used to have here is we used to have the physical servers. Only the people or else the companies which is having very high revenue, they are able to offer the physical server. So for example, I want to purchase a server. It will cost us somewhere like, if I take a bare minimum server also, it will cost me some 3 lakh rupees. So with that, I am going to purchase a server. So this is my physical server, which I am going to purchase. Either it might be rack server, tower server, or blade server. So if you can see rack server, so this kind of servers we are going to purchase. Yeah. So this is the rack. Inside this, we will have these kind of servers, and this is a blade server, and this is the tower server. So now what is happening? We will be purchasing these kind of physical servers. Bare minimumly, that will cost around some 3 lakh rupees minimum. I'm talking about the minimum 3 lakhs rupees, 2 lakhs, 3 lakhs rupees of cost. Inside the server, we are going to install an operating system. Either it might be Linux operating system or else Windows operating system. In Linux, again, it might be Red Hat Linux, Ubuntu Linux, any kind of Linux operating system we are going to run on this server. So when we install the operating system on the server, so now what we can do inside this operating system, we can deploy our applications. So whatever the application that we have created, we are going to deploy that. So now if we are provided with a server, if we are provided with a physical server by the data center, we are going to deploy this application. For example, I have created this application, or else my Java developers has written the application on Java 11. Okay, so on the Java 11 and everything is fine. So from their perspective, from in their computer or else in their desktop, in their workstation, the application will be running fine. Why? Because they don't have these vulnerabilities. They don't have multiple applications that are running inside their computers. They are having a single application which they have developed, and they will install all the requirements. They will install all the upgraded requirements and everything. They are going to create it. So now, as my Java developers has developed this application, this is an obsolete one. Java 11 is not nowadays. Nobody is using that. Everyone has migrated to Java 17, if I am right. And then now it is now coming. Java 21 is also available, and Java 25 or 24 is the latest version that is into the market. So now Java 11 is now nobody is using, but you have created the application on Java 11, and I need to deploy this on this operating system. So I have deployed this. So you have created certain plugins which are related to Java 11. This application has to support that. So all the plugins that are supported by this application, you created those plugins, you connected those plugins to this application, and the application is running good on the development environment. Now, there is another application that is created by my developers, and this application has to run on Java 17. I have only single server. I don't have multiple servers. I don't have that economical status of purchasing the multiple servers. So I'm having only a single server. Now I want to run this Java 17 or else Java 17 application on this server. Is it possible to run multiple Java applications not in this situation? You can say that Java alternatives are available. Yes, of course, I totally understand. I accept that. But if you go back to some 10-15 years back, do we have those Java alternatives? Is it possible to run the multiple versions of the application on a single server? That too, if you say Java 17, I have created. So in Java 17, whatever the application is running, so the application should be running with the required and compatible resources. Java 11 application will be running with its own compatible resources. Whether these two applications will be running on a single server, is it possible to run two different versions of applications? So this application belongs to some X bank, and this application belongs to some Y bank. If I want to run these two applications on a single server, is it possible right now? Do you understand the concept here? So the server is having some 16 GPU. Don't worry about the resources, some 256 GB of RAM. So that's more required number of specifications are there. We don't need to worry about the resources. So this application maximum will consume some 2 CPU, somewhere like some 16 GB of RAM mostly. Apart from this application may consume the resources like again 2 CPU and 16 GB of RAM. So you don't need to worry about the resources. Resources are abundant, number of resources are available. So we don't need to worry about the resources. But what we need to worry here, whether these applications are compatible or platform dependent. So the applications are platform dependent, and as well as these applications, whatever you are running here, they are of two different versions. Whatever the plugins and whatever the what I can say, uh, what was the dependencies, whatever the dependencies to run that applications are different. So in first application, the dependencies may be in a lower level dependencies are there. When you come to the Java 17, they require high level dependencies. So my question is, can we run these two applications similar? I mean, in a same time, is it possible to run these two applications on a single operating system, on a single physical server? Is it possible? Yeah, guys. Java developers, you might have the knowledge of this. So can you please tell me, is it possible to run these two applications on a single server?
Yes.
How?
Uh, it's a concept of virtualization, but what we are talking Docker right now is
I'm
basically.
not talking about the Docker. I am talking about the on-premises servers. I am not sitting right now like just today or else just 1 year back. I'm not talking about the story related to 1 year back. That's why I made it very clear. This is the physical server in which I am installing the operating system and I am bound to run two different applications on the same server. So don't go with the Docker and virtualization concept. Come back to some 20 years back, you are having a single server and inside that server, you need to run the application. You are having a single physical server. I did not talk about the virtualization. Okay.
You're talking about the on-premises.
I am talking about the not in on-premises also you can run the virtualization. So just forget about the virtualization. I am talking about a single physical server. You are having a single physical server. Inside that you have to run the two different applications which are having two different dependencies and those
No,
dependencies.
no. That's the possible in the single server with the two different platforms, like two different versions or whatever. It will be
So
not
you,
possible.
yeah, you are going to get the compatibility issues. So
Exactly.
either you can run Java 11 application or else you can run the Java 17 application. At a time, if you want to run two applications, in right now it is possible with the help of Java alternatives and the other way it is possible now. But when you go back to some for 10 years back or 15 years back, it is not possible. So now what has done? So this is my single on-premises environment server. This is my physical server. So now from this physical server state, what has happened here is the IT industry has developed a new technology called as virtualization. So the new technology called as virtualization. What is that virtualization? Here you will have a server. So inside the server, you might be having the same physical resources, 16 CPU, 256 GB of RAM resources are available. So these resources will be what I am going to do here is with the help of virtualization concept. Okay, with the help of virtualization concept, I'm going to divide this physical mission into logical virtual missions. So how we are going to divide that? So if you can see, this is my computer. So my computer is having 16 CPU, I mean, somewhere like 16 GB of RAM and 3.56 gigahertz of processor is there. So now I will just open one of the virtualization platform. This is my Windows computer. So I am having a virtualization platform. Here I can run my Red Hat virtual machine and as well as I can run my Windows virtual machine like this. So these virtual machines are going to consume my resources. So if you can see whatever the resources that I am having right now. So whenever I open the virtualization platform, see that the memory is slowly increasing, which means that these resources are consuming my physical resources. So now how it is happening? So now I am having a physical server. There are two types of virtualizations, any which ways we are going to discuss about that. One is the bare metal virtualization, bare metal, and the next one is hosted virtualization. So this bare metal virtualization is also called as type 1 hypervisor and hosted virtualization is called as type 2 hypervisor. Hyper-V. Okay. So what is this type 1 virtualization and what is the type 2 virtualization? Let us discuss about that. So now when we purchase a physical server, so the physical server I have purchased, inside that if you are having a CPU, if you are having the CPU that accepts, that is having the compatibility for virtualization. Okay. So the CPU should accept the virtualization. So if you are having the CPU that is compatible for virtualization, then what we can do here is directly onto the server, we are going to install the virtualization platform, that is VMware ESXi, or else hypervisor, Windows hypervisor, or else we can install what I can say, tricks. Okay, any certain virtualization platforms we can work with. So here I am going to install VMware ESXi. Most of the companies will use the same software. So on the top of this, we are going to create a virtual machine. So this virtual machine, whatever is created, so this virtual machine will get the resources. So the virtual machine will request the resources to the VMware. So the VMware will provide the hardware resources by communicating with the physical server and provide the resources to the virtual machine. So now we are creating a virtual machine here. So this is my VM1. So inside this virtual machine, what I can do here is I can install an operating system, like how I have installed the Red Hat operating system in one of the virtual machine and Windows operating system in the another virtual machine. In the same manner, here also by directly VMware ESXi is going to communicate with the physical server and it is going to allot the hardware to my virtual machine. And inside this virtual machine, we are going to install an operating system. Either it might be Linux operating system or else it might be Windows operating system. A OS will be installed. And inside this operating system, we are going to run the application. Here we will have the application running. So this application may support the Java 17 or Java 11 like that. So this is the application. So now this virtual machine, whatever the VM that we have created, it can support up to 2 CPU, some 16 GB or else 32 GB of RAM. So this 32 GB of RAM will be given from the physical hardware. So from 256 GB, if you remove 32 GB, still you will have somewhere like 224 GB will be available. And then we are going to create one more virtual machine to run the second application. So this time also I'm going to create the same virtual machine over here. So there will be virtual machine inside that we are going to run the operating system, and inside that we are going to run the application. So here we will have the application running. So who is providing the resources? So to provide the resources, we will have a mediator or else we will have an interface so that the virtual machines will communicate with the VMware and this VMware will communicate with the physical hardware and it will provide the resources to my virtual machine and that virtual machine will run the application. So this is what going to happen. So this is called as bare metal virtualization. Bare metal, where we are having physical hardware. On the top of the physical hardware, we are going to run the virtualization platform. On the top of that, we are going to run the virtual machines. Inside that, we are going to install an operating system, and inside that, we are running the application. Now, when you see here, whatever the virtualization that you see in my laptop, so this is called as hosted virtualization. Whatever you are seeing here, this is called as hosted virtualization. What is going to happen here? First of all, we will be having the hardware. So right now I am having my physical hardware. Here you can see somewhere like some 8.5 GB of memory is consumed and some CPU is there. So now here you can see there is a hardware. Hardware. On the top of the hardware, I install my host operating system. What is the host operating system I installed? The host operating system which I installed is Windows 11. So this is the Windows 11 operating system which right now I am having. So on the top of this host operating system, host OS, on the top of this host OS, I install a virtualization platform. So here I install the VMware workstation. So this is called as hosted virtualization. On the top of this VMware, I just install the virtual machines. On the top of this virtual machines, I'm running I installed my operating system. I have installed my operating system. So this is my VM1 where I have installed the Red Hat operating system. Okay. And inside that operating system, I install an application and running it. So this is my RHEL. And here we are running an application. So this is called as hosted virtualization. Now, what is the difference that you find out with the bare metal virtualization and the hosted virtualization? What is the difference that you find out between the bare metal virtualization and hosted virtualization? Tell me, you don't find any difference?
You have a OS on top of it,
Hmm.
host OS. On
Mhm.
top of that, you're having two different.
So that's the main difference. Hosted virtualization and bare metal virtualization. On hosted virtualization, we will have the host OS. And in the bare metal virtualization, we will have the VMware. Directly, we are going to use the virtualization component. So this is the main difference. So now, whatever you are seeing, from where we are getting these resources, whatever the servers that you are seeing, these servers will get the resources from my physical physical computer. Okay, so if I close the, or else if I shut down the server, automatically the resources will be released. So now this is called as hardware virtualization. This is called as hardware virtualization. Whatever you are seeing, either it might be hosted or else bare metal virtualization. This is called as hardware virtualization. Now, what is the benefits with this? So with the benefits with the hardware virtualization is that optimized usage of resources will be there. Okay, optimized usage of resources will be there. So this is called as hardware virtualization. So which means that if you want to create, if you want to run multiple servers, whatever the servers that are provided by the data centers, whatever the servers that are provided by the cloud environment, they will follow this hardware virtualization only. So simply we are going to roll out a server. So if we request a data center to roll out a server on this, so what they are going to do? So they are going to go for the hardware virtualization. So they are going to install a server and they are going to run the server on our required environment, on our required or on their physical server. So like this. So there will be multiple virtual machines we are going to create on a single server. So this is how the data centers are going to provide the resources for the end customers. This is fine. Now, what is the main drawback of this virtualization? The main drawback of this virtualization is that, see, I said you in the previous example, so the application which is created inside this development server, so this application has to be moved into the UAT and production environment. So to move that application, so if I move only the application, try to understand this in a simpler way. If I try to make you understand in a simpler manner, if I want to move this application only, so in the development environment, it is the developers and the system administrators who will communicate with each other and they will create a server, they will create the application depending on their requirement. So the developer will say that the application will not run with these dependencies. So you have to install all the dependencies in the development server. So as the system administrators will have the total access for the development server, they will install all the dependencies. They will run all the applications, whatever that is requested by the Java developers, they will do, I mean, whatever that is requested by the developers, the system administrators will do that. But when this application is moved into the production environment, or else at least for the staging environment, where already there are a few applications running on the servers. So if already some of the applications are running on the servers, if you want to run this application, then there will be a compatibility issue. So this application will not run on this UAT server. So then if you go back to the banking people and say that, so we have the compatibility issue, we don't want this server to be given for us, we want a different server, then banking people will say that no, it is not possible. So you have to run the application on the same server. So if you try to run the application on the same server, then there will be a compatibility issue. There is a compatibility issue, you cannot run that. So that is what. So previously one person said that platform independence. So here those are the platform dependent. Okay, so now whatever the application that you are seeing here, this application will be totally having a compatibility issue. So the application will not run. So either the developer has to back off and reconfigure the application as per the requirements, or else he needs to go with a concept of platform independent. Okay, so for that, what you can do, either you can go with the virtualization concepts. So in this virtualization concept, you will say to the development or the banking team, so, okay, we are having a virtual machine. We will pack the entire virtual machine and give it to you. So you run that virtual machine on your server. So, but physically, if I have to talk, technically, if I have to talk, So packing of this entire virtual machine is very, very, very complicated. Why? Because so here we are not packing only the application. Here we are packing the entire virtual machine. So which means that we have to pack the virtual machine, we have to pack the kernel, we have to pack the operating system. Inside the operating system, whatever the unwanted applications are there, we have to pack those unwanted application, and then we have to pack the application and its dependency. So if I have to do all these things, the size of that package will be very, very high. So if you see, just like whenever you are traveling from your home to certain location, you want to visit a temple near to your hometown, or else if you want to visit to a temple which is in some X location or Y location, if you want to visit to the temple, are you going to pack all your luggage, the entire bed, kitchen, whatever the kitchen things are there? Are you going to pack all those, or else are you going to pack only the clothes? How you are going to pack that? Whatever the dependencies are there, you are going to pack only those. You want certain clothes to be there, so you will pack only the clothes, and then you will go to that temple, or else whatever the wherever the place that you want to visit, you will go there. You won't pack everything, no. So in the same manner here, what is happening? If I want only application, why I need to have the virtual machine? Why I need to have the software operating system? Why I need to have the unwanted dependencies? So I don't want all this scrap. So this is causing a lot of issue. If I have to pack this virtual machine, it is going to cause me a lot of issue, where it is getting packed with the operating system and as well as the unwanted dependencies and the application and its dependencies. So to migrate this, it is going to take a lot of time. So to overcome this problem, not only that, so there will be compatibility issues, everything will be there. So to overcome all these problems, we are going with a concept called as software virtualization. And that software virtualization is called as your Docker. So we are going with the software virtualization, where we don't have the operating system. We don't need to install the operating system. We don't need to have the kernel. We don't need to have the unwanted dependencies. Inside the container, you will have only application and its dependencies. So it will be very, very lightweight, so that you can migrate from one location to the another location. So you can simply say to the customer, so as the application, we have the containerized application. So let us install the Docker on your server, and once the Docker is installed, this application can be easily migrated to this UAT environment, and we can run the application on the container, and this container will be exposed to the end customer, so that they will be able to access the application. We don't have to worry about the uh, dependencies. All the dependencies will be packed inside the container only. So that is what we call it as software virtualization. So this is the main concept of why we need to go for the containers rather than the virtualization. So in virtualization, what is the main drawback? In virtualization, we have to pack the entire virtual machine, operating system, unwanted dependencies, which is going to be very heavy weighted application. When you come to the on-premises environment, in the on-premises environment, obviously you are having the compatibility issues. You will be having the low level of resource utilization. Everything will be there. So to overcome all these problems, whichever you are facing with the physical servers and your virtual machines, we are going with a concept called as containerization, software virtualization. So what is meant by containerization, and how we are going to work with the software virtualization? What is container? How containers are derived? How we can define the containers? Everything we will discuss in the next session. I hope you understand about what is meant by a containerization. Any questions here? So I will stop here. I'll stop here. Do you understand the concept of why you need to go for the virtualization? Any questions?
No.
Hmm?
No.
I don't have a question. I'm still
Hmm.
trying to clarify the the left image, where you had a physical server and two Java apps, 11 and 17. So we said that that is not possible, that they can exist together. So, but because Java itself is platform independent because of JVM. The reason I said that was because JVM is platform independent. if we run one in one server and the other in another server in the same physical server, for example, there could be a Tomcat, there could be Netty, we can have Java 11.
One second. So you are talking about running the two applications. So where Java is platform independent, that is what you are saying.
The
Now
left
let me,
image.
I am talking about that. Okay, let me talk. So if you are having a Jenkins application that is running inside this Java, I mean running inside this physical machine. Okay. Jenkins will support Java 17. Right now, Jenkins doesn't have support for Java 11 and Java 8. Now in the same server, if you run the application that will be compatible with Java 11.
Yeah.
I'm not talking about 2025. I'm talking about 2005. In 2005, you won't have the virtualization concept, right?
There's no virtualization. JVM has existed. JVM is a virtual machine, right? JVM has existed ever since Java was born.
Have you tried running the two applications without alternatives like Java 11 and Java 17 application in a single physical server?
12 years back when I started my career, one of the company I was working for, they were doing that, but they were not the web applications. One was simple app. So they had configured the environment variable, one pointed to something else and another pointed to another JVM instance. But they were all on different web servers, you want to call that, or application servers in the same big physical server.
So that's what you are talking about virtualization. Again, you are coming back to the same point.
So
So
if we were not be talking about Java, then definitely but Java, when we talk about Java, virtualization is a core concept in Java. JVM is virtual machine, right? So JVM is a virtual machine. It provides platform independence in Java.
any which ways, I tried myself, okay, with my experience.
No, I mean I am clear. But after that, when you
Okay.
explained the transition to the containerization, that made me more clear into but why containerization is required. So I'm clear on that part completely now.
Okay.
Shall I add one point here? Hi. Yeah,
Hi.
you were talking about Java virtual mission. Java is a purely platform independent, that's right. But if you're talking about the independent platform independent, it's a dependent from the different OS. For example, you are developed the application in the Windows, you can run the application in the Ubuntu mission or a different server OS. But if you are develop the application in one version, for example, Java 11, and you can deploy this 11 application and the deploy one more application in the Java 17. You can't deploy the both the applications in the single. Why? Because yeah, obviously Java is in a platform independent, but it's a platform independent means not in a different versions, it in different OSs. You can run the application in a different OS. Not
So
that's the
what
reason
you
in the
do is,
JVM.
Okay. Hold on. See,
I think
just forgot.
it
I totally understand. Yeah, one is supporting me and the other one is. I'm saying that everyone are okay with the concept, but the point, just forget about the Java. Just forget about. So we can run one Java application, one Python application, or else one Java application, one .NET application like that. So they will have two different compatibilities. Maybe they might not be in a single physical machine. Just understand like that. So don't go with compare with the Java things, Java applications. Just forget about the things. But the point is, you will be having a compatibility issues if you are running the multiple application on a single server, single physical server. To overcome that, we are going with the virtualization platform. From there, why we are going with the containerization? Because of to overcome the overweight of that application packages. Okay. So any which ways, thanks for supporting me. Anyways, so the point is here, I hope you are very clear about why we are going for the containers. We don't want to have a clear-cut high-level discussion about Java, JVM and everything. So it is going to take us to a different level of arguments and different level of discussion on that. We don't want to do that. We are into a concept of containerization. Why we want the containers, why we are going with the containers. Okay, so that's more important for us, not about the Java application at all the things. Okay. I hope I made it very clear for you related to the containers. Is it clear? Any questions related to the containers? We'll discuss about what is meant by a container and how we are going to work with the container any which ways in the next session. But up to now, whatever we have discussed, just forget about multiple versions of Java, multiple JVMs and everything. Okay, just keep in mind that we have an application overhead. To overcome that, we are going with the containers. So to explain you all those things, I gave you a small description about what is happening. Okay, so further we will discuss about the upcoming things, what is happening, what is not happening. We'll discuss later. Okay, so we don't have to have a very debate, very highly aggressive debate on this concept. We need to have a clear-cut group discussion on understanding about the containers. Okay. I hope I made it very clear for you with what is meant by a container, why we are going for the containers. Any questions related to that?
I just have a quick question on this virtualization.
Hmm.
So we said 2 CPU and 32 gigs, right?
Hmm.
Are they like fixed sorry, are they like fixed allocated, for example, in the
I took
VM1?
an example over there. How
No, no,
can
what
I define? How can I define an application will require only 32 GB of RAM? An application can run with 8 GB or 8 GB RAM. That depends on the development.
I think my question is so when we do the virtualization in VM1, any CPU X number out of Y, so are they always fixed that only this much memory and
No, we can increase that. If you want, we
okay.
can increase, or else if you want, we can decrease the memory and so it's not a fixed rate.
Okay, so this is also a part of virtualization.
Right? Anything else?
Chaitanya, I
Yeah,
have a
Kishore.
small question. It's not related to the technical. The demo session is 8:30. What about the regular classes? Is the same time or a
Regular
different time?
classes will be at the same time, 7:30, sorry, 8:30 to 9:30, 9:45. Sometimes it may
Okay.
go up to 10 o'clock also.
Okay.
Regular
Thank you.
classes will be at 8:30.
Okay. Thank you.
Hmm. Anything else? Ram, Vishnu?
The course duration is like
20
4
days.
weeks. Okay.
20 days, 25 days. Sometime you will have the sessions on Saturday and Sunday also. We will discuss about this as I have another session at 9:30 planned.
Okay.
So, yeah. So we'll discuss about the course duration, course syllabus and everything in the next session, where we are going to discuss about the concepts related to what is the Docker, what is meant by container, what is the syllabus, what is the course duration. Course duration 20-25 days, most probably. Weekends will be there. So I won't say every weekend you will have a session. A few weekends you will have the sessions. I will tell you at what time you will have the session. Before 3 days before, I will give you the uh, on that weekend whether you are having the session or not. Okay. All right, guys. Have a nice day, and we'll meet in the next session then. Bye.
Thank you.
Thank you.
Thank you, Chaitanya.
Thank you. Thank you all.